first number be x. Let the first number equals to x, and the second number, Kisha, were you able to do it? No? And the second number is y. Alright? Easy? No dramas here? What's the first line tells us? It says sum is 4. So can I say x plus y equals to 4? Who has done this till this point? Were you able to do until this point? This was fine. This is elementary.
Yeah.
Aishka?
Yeah.
Yeah. Next line could be tricky. It says such that the sum of the, so we're trying to find the sum now. We need to find the sum of something. The sum of cube of the first, can I say x cube, of the first, and the square of the second, y square. Yeah?
I have a question.
Hmm.
Can they be fractions or not?
Yeah, there could be fractions. Yeah. And there are fractions here. Right. So I now, so that's what the writer tells me is as small as possible. That means minimum. So I need to find that this needs to be min. As small as possible means derivative. So let's say now this is the function, so I need to plug something in here. So this is z, right? So I need z to be, I need to find the values of x and y in such a way that the function or the z is minimum. If you are able to reach to this point, 80% of the battle is won. But then if you're not able to reach here, you won't land anywhere. So what's the best way? If you're not able to decipher this, what do? We practice. We practice hard. That's the only way to go, right? Okay. Now, how can I find this to be minimum? What do I do? Easy. Come on, who's telling me that? Ryan, what do I do here? Tell me. I need z to be minimum. What do I do? Say something. It's okay. Even if you don't say, don't know. Finish. I move on.
Yeah, no.
All right. What about you, Chris?
Re-express one of the variables.
Sorry.
Like say x in terms of y.
What do you think, Isha? What should we do here?
Can we derivative?
We are finding the derivative, yes, but then the problem of finding derivative is got x and y here. I just need either x or either y. So only then you can find derivative, right? With respect to only one variable. You can't have two variables on the other side. Aishka?
I made x equals to 4 minus.
Good job. So what Chris just said, you have y equals to 4 minus x. Either you can do that, or you can say x equals to 4 minus y. Which one would you prefer? So if you are plugging in, Chris, if you are plugging in y here, so that means eventually what you're going to find is dz by dx, because everything will be in x. But then if you're plugging x here, then you will be finding dz over dy. Both the approaches are fine. Which one is the preferred approach? What will you do here? Which one will you take? And why you will, and why? Both the approaches are correct. One of them is easier. The other one slightly sort of challenging. And if this is a non-CAS question, let's say, then. See, if you say y equals to 4 minus x, you land up here, x cubed plus 4 minus x whole square. Then the only challenge will be this bit, right? And you said dz by dx, then you find d by dx of this and d by dx of this, right? But then if you were plugged in x, then your function would have z equals to 4 minus y cube plus y square. Now, if this doesn't come into your brain, then the problem is you need to expand the cubic here, which is not that straightforward. Here, you can expanding the squares are easy, so you can use a minus b whole square formula, which is a square minus 2ab plus b square. Whereas a minus b whole cube, you might not know unless you're written in your formula sheet or it's given to you. So always sub in something which is easier to deal from a calculation perspective. If I were you, I would have gone subbing in the y, right? And then you find the derivative, and eventually you equate the derivative equals to 0 and you find x. So what will happen here is when you will equate it to 0, you will get a quadratic. And that quadratic will be equals to 0. Then quadratic formula, and that will give you the value of x. Is the approach clear to you? See, I'm not doing the question per se straight away, but what needs to be done in the question has to come into your head step by step, right? Ayushka, does that make sense? The approach makes sense,
Yeah.
right? Ryan, that's how you approach, right? Kishan, all good, right? Cool. And we can do many more questions if you want. Now, I'll go to, and I wanted to do one more question, but I think I will run out of time. I want to give some introduction on integrals and right in the left estimation point, and we'll just go from there. You want to do one more question at least, or you want me to move to integration? What's the take on it?
Can we do integration?
Integration? Yeah? Alright, cool. The world of differential calculus or differentiation helped us find rate of change. Rate of change of y with respect to x, and we used to call it as dy by dx. Integration is a different ballgame. Integration helps us, in a very layman terms, finding area under curves. So, for example, if I've got this kind of straight line, and let's say this is 0, and this was 10, and this is, let's say, 15. If I tell you, okay, find me the area under the curve here until 10, find me the area under the curve. So it's easy, right? This is a triangle, right angle triangle, and you can say half base times the height. What's the base? Base is the 10, which is half times 10 times, what's the height? That's the height, 15. Correct? So which is 150 over 2, which is 75 square units. Now, this was straightforward. If you have something like this, and I say, find the area under this curve from here to here, from A to B. Then it's a challenge. And that is where your integral comes into the picture. They help you find areas under the curve, right? In its very, very simplicity. Let's try to, shall I take this off?
Yeah.
Let's take an example. Let's say, I'll grab the book. You have a graph like this. And I'm asked to find area under this curve. Here, all of that, this side. It's not a perfect rectangle, triangle, right? So one way is that I start drawing from the left. I start drawing rectangles. So let's say I draw rectangles in such a way that, okay, that's the first rectangle, that's the second rectangle, that's the third rectangle, that's the fourth, equal rectangles basically. Right? And since, and let's say they're equal, so they are 1 unit apart, right? There's 1, 2, 3, 4, 5, 6, 7, 8. And the height is the same, right? Let's say this was 10. So what am I doing? What's the area of one rectangle? 10 times 1, which is 10, right? So one rectangle here is basically 10 square meters, 10 square units. And then since they are equal, so they're 1, 2, 3, 4, 5, 6, 7, 8. 8 rectangles, so I can easily say 10 times 8 is 80 square units. Must be the area, approximately the area under the curve. But now there is a problem. You can argue that you've covered all of that as well. Stuff that's outside the curve. So this 80 square units must be this 80 square units, the area under the curve must be less than 80 square meters because you've counted a bit of extra here. Right? Now let's take another approach. Is this clear, Chris?
Yeah.
So far? Let's take the same curve, another approach.
What's the name of that approach? Is that like an actual thing? What's the name of that approach?
The left endpoint estimation.
Okay.
I'm coming to that, don't worry. Same curve. Let's say this is 10. Now, rather than drawing the rectangles from the left, I start drawing rectangles from the right. I say, okay, that's the one, that's the one, that's the one, another one, maybe another one, 1, 2, 3, 4, 5, 6, 7, let's say they were 10, right? So suppose I've drawn now 10 rectangles from the right to left. And now I know the area of each rectangle. So how do I find the area of each rectangle? In this case, so now I find the area of each rectangle and I times it by 10. So I'll say area times 10. But then, and let's say this was 60 square units. But then now there's a challenge. You would say, oh, you've left these gaps here. You know, you've left these gaps here. So that means the area must be greater than 60. Yeah? So this left estimation gave me a value where area was lesser than that value. In the world of right estimation, I got a value where the area was greater than that value. So I can confidently say that my area must be between 60 and 80 approximately. Make sense? Yes or no?
Yeah.
Cool. Here, the lengths are pretty much the same. The widths could be different, right? So you can find what this value is, you can find what this value is, what this value is. Their height must be going down, right? They're not equal, and you land up here. So this is called the right estimation, and this is called the left estimation. Make sense? Yeah? Right and the left, or right end point estimation. Right end point estimation, and that's the, sorry, left end point estimation and right end point estimation.
I have a question.
Mm-hmm.
For the left end point estimation, why do we go like why do we have to? Why don't we just go down?
Where? Here?
Like, why don't we just take the left point and then just like do a line and then?
Okay, let's draw it again. Let's draw it. So you're saying something like this. So okay, what do I do now?
So you take the left.
So you say, okay, oh, all right, got your point.
Yeah, like that.
Okay, good, very good point. Thank you very much for asking. Thank you very much for asking.
Because I think I did that last year.
Can you tell me what will be this value here? This value here.
No, like you make it into a rectangle.
That's what we've done here. No? That's what we've done here. No? You see? That's what we've done.
Are you saying from like the line, right?
Yeah,
You see
like.
here? You see, I draw a line
Yeah, that's what I meant.
and I just draw the rectangles, right? That's what I've done here. No? I draw the line and draw the rectangles. Exactly the same story.
But why are they all the same height?
Sorry?
Why are they all the same height?
The same height
Yeah.
here.
Yeah, why are they all the same height?
So what heights they should be?
Like you take the left point and then you just do the line according to
Good job.
its actual length.
Good job. That was a good pickup. Right. So we'll extend this thought to finally converge it to what you just said, right? We've run out of time. So I will now converge this thought to what you've thought. We need to know the function to find this value, this value, this value, this value, this value, right? That's what you're talking about, right?
Yeah.
I did not give you the function, so I just sort of made something up, right? I need for this value, I need to know the f of x, no?
Yeah.
I need to know the f of x. So we'll extend this thought next week, and we'll tweak it and we'll move into the world of integrals,
Okay.
right? Cool.